When you hear the word chemistry, what comes to mind? Probably beakers, maybe some lab coats, right? But what if I told you it's so much more than that? Really, it's the story of transformation. It's how a single cell can become a living, breathing creature. It's how we turn a boring lump of rock into the smartphone in your pocket. It's like the fundamental code that explains, well, everything. And today, we're going to decode it together.
So where do we start? Not in a lab. Our journey begins right here with this. The world's largest single cell, an ostrich egg. On the outside, it looks pretty simple, right? Kind of inert. But inside, something absolutely incredible is about to happen.
I mean, think about it. How does that happen? How does a simple collection of yolk and white and shell turn into a living, breathing creature? One with a beating heart and eyes that can actually see. It seriously feels like magic. But the truth is, it's something even more incredible. The answer? Well, it's this invisible microscopic dance. Billions upon billions of atoms are constantly breaking apart and then reforming into something new. And they're not just doing it randomly. Nope, they're following a super precise set of instructions written right into the DNA. So no, it's not magic. It's just an absolutely astonishingly complex chemical process.
Okay, so to really get how that chick is formed, we've got to understand the rules. The rules that govern this whole intricate dance of atoms. Let's call them the rules of transformation. And yeah, those rules, they have a name. You guessed it, chemistry. It's simply the study of how all this stuff works, how things combine, how they separate, and how they create entirely new substances out of the old ones. It's kind of like the instruction manual for the entire universe. Here's a really great way to think about it. Think of atoms like a chemical alphabet. The whole universe is built from just about 100 different types of atoms. Think of them as our letters. But just like with our 26 letters, by combining these chemical letters in endless ways, you can write an infinite number of stories. The story of a rock, the story of a rose, or yeah, even the story of a living creature.
Okay, check this out. This simple little experiment shows exactly what I'm talking about. On the left, you've got some iron filings just mixed in with sulfur powder. A magnet can easily pull the iron right out, right? Because they're just hanging out, sharing the same space. But look at the right. After we apply some heat, the magnet does absolutely nothing. Why? Because it's not iron and sulfur anymore. It has become something entirely new.
What we just saw, that's a chemical reaction. The iron and the sulfur, those are what we call the reactants. And after you heat them, they transform into that new stuff, iron sulfide, which we call the product. The key here is that the fundamental identity of the matter has completely changed. All right, so we've got the basic rules down. Now let's see how nature takes these exact same rules and uses them on a scale that is just mind-bogglingly intricate. Just think about this for a second. Every single living cell, in a plant, in an animal, right inside you right now, is basically a microscopic chemical factory. It's running thousands of different reactions every single second, just to keep you going. And there's no better example of nature's elegance than photosynthesis. I mean, come on. A plant cell uses that green stuff, chlorophyll, to capture sunlight. Then, through a whole series of chemical reactions, it turns that light energy into chemical energy. Basically sugars. It's a perfect, self-powering little factory that is literally the foundation for almost all life on Earth. It's amazing. So, okay, nature is the undisputed master of chemistry on this tiny microscopic scale. But what's really interesting is that over the last few hundred years, we humans have figured out how to take those exact same rules and apply them on a massive, world-changing scale.
So let's break it down. Nature's method? Billions of tiny, super precise DNA-guided reactions happening inside a cell. Our method? We build these huge engineered processes in giant refineries and factories. The scale could not be more different, but the fundamental principles, they are exactly the same.
And we use this knowledge to, well, completely reshape our world. We take crude oil out of the ground, and through a bunch of chemical reactions, we rearrange its molecules into these super long chains called polymers. And what do we make from polymers? Plastics. All of them. Or think about this. We use advanced chemistry to pull a super strong lightweight metal like titanium out of what is basically just ordinary rock. So we've got these two very different pictures, right? On one hand, the delicate, intricate chemistry of life. On the other, the massive, powerful chemistry of industry. But here is the most incredible part, the big takeaway. They are not two different things. At their core, they are one and the same.
I mean this literally. The exact same fundamental laws that guide atoms to build a chick inside an egg, those are the very same laws we use to create plastic from oil. It's all one universal chemical code, a code that writes the story of everything from the living to the manufactured. And understanding this universal code, well, that gives us incredible power. The power to create new medicines, new materials, new forms of energy. It really is the key to our future. So the only real question left is, what are we going to transform next?